or focus? I mean, are they the same thing basically?
You're going to get the same numbers.
Oh, so you were just kind of like translating it to
Yeah.
like an
Yeah.
easy term so you can understand. Okay, I get it.
Yeah. And I really, I mean, I guess there's some statisticians here that would probably, you know, like die hearing me say this. But really, I think for you guys at this point, they're interchangeable. You know, obviously later, they're not, you know, it's, you know, I'm not trying to tell you population mean is the same thing as sample mean. They're not, right? But for us in calculating these numbers, they're the same. It's the same, it's the mean, okay? And I don't want you guys to stress right now about, oh my gosh, is that the population mean or is it the sample mean? Which one do I use? It's just whatever the raw score is minus the mean divided by the standard deviation. Okay, yeah, really, Natalia, going forward, there is not a lot of times that we know population mean and standard deviation. That data is just, I mean, it's like virtually non-existent. How do we know what is the population mean of people's attitudes towards, I don't know, some person, you know what I mean? Like we just don't know that stuff. So very, very rarely do you ever have true population data. Okay, so that's why a lot of times we just switch to sample, right? Because we don't always know that population information. Okay, yeah, but good question. Good question. Okay, so a little bit into what does this mean and what are we talking about with z-scores? Okay, let me see, I put this up here but I don't know, oh, this was just another example, so I'm gonna wait on that real quick. Go back, sorry, wrong one, home. Let me put in a new slide here for me to scribble all over. Okay, so let's go with something that we know exists on a normal distribution. We know height and weight are normally distributed across the population, but the problem with height and weight is it depends on if you're male, it depends on if you're female, and then of course it depends on your age, okay? And so I don't know, I don't have all those numbers in my head. However, IQ is normally distributed, and it just is, it's the same, it's super simple. I have that in my head and I'm going to pass this information on to you now. Okay, so I am going to kind of move this so I can sit here and try my best artwork. Okay, so let's see. I'm not going to use red, I'm going to use black. And then let's, okay, so here is a nice line. I did pretty good there. And I'm going to draw on this nice line, this normal distribution, okay? Please don't judge me. I know it's not perfect, but in your head, imagine that everything is straight, everything is symmetrical, and it's the way it's supposed to look, okay? All right, right here in the center, I'm going to draw a, that's a 0, okay? I'm going to have to really let my OCD go a little bit. Okay, and then we have on a Z distribution, we would have a 1 right here, we would have a 2 right here, we'd have a 3, and then a 4, okay? And then remember, well, a Z distribution and a normal distribution are, I guess we could say interchangeable, but I mostly want to say they are, they're like exactly the same. Like you could overlay one on top of the other and they will fall in alignment, okay? So a Z distribution is a normal distribution, okay? So what that means is what happens on one side is true on the other side, okay? Now I can really see how lopsided and not symmetrical this is, but please play pretend with me that it is it is symmetrical, okay? All right, so what we have over here listed are these z-scores, okay? I have 0 right in the middle, and then they can move up 1, 2, 3, and 4, and then down -1, -2, -3, and -4. Okay. Oh, that got worse. Okay. Now, IQ is normally distributed. Therefore, it's a normal distribution. Therefore, I can overlay it or put it on top of this Z distribution. And I'm just going to write this one right down here and the numbers underneath it so you can see where and how they fall. God, that looks bad. So our average our average IQ is 100. Okay. Oh my gosh, it's not getting any better, but okay. So it's 100. Average IQ is 100. Okay. And I'm going to do the population mean. God, that doesn't look good either. Is 100. Okay, if you're asking where I got this information from, I got it from my head, which was told to me a long time ago. You can look it up. This is just known information within like the psychology world. It's known information within the statistics world. And now I'm passing this information on to you, okay? It's widely known, it's widely accepted. And so just trust me on, oh my God, trust me on that. Standard deviation for a population, kind of. It's 15 in IQ, okay? The standard deviation in IQ is 15, okay? Again, you're just gonna have to kind of trust me on that. But please, by all means, you can look it up and quiz me, okay? So standard deviation units of 15, all right? So what that would mean is one standard deviation above would be 115. 2 standard deviations above would be 130. 3 above would be an IQ of 145. And 4 above would be an IQ of 160, okay? Einstein was believed to have an IQ of about 160. We don't have many Einsteins walking around, right? You can see that that is pretty rare. Remember when we talked about anything beyond 3 and -3, that's really, they're outliers. It's really rare, okay? All right, now we're gonna do it on the other end. Okay, so we're subtracting our standard deviations. This one would be 85. I don't like my 8. All right, this one would be, no, not 60. It would be 70, 55, and then a 40. All right, if someone wants to check me if those are correct. It's been a little while since I've done IQ. 85 minus 15, 70, minus 15, 55, minus 15, 40. Yes, okay. Real quick, anybody have any questions about where the numbers came from or what in the world is this drawing?
So are you basically either going down or increasing by 15 from the standard deviation, or the numbers below?
Yeah, that's right. And that's just for IQ,
Oh yeah.
Natalia. Okay. if, or like if we think of in that example where it was the psychology tests, our standard deviation was 10, we would be moving in units of 10. Okay, this one we're moving in units of 15 because they told us that the standard deviation was 15. Okay, so if we go back right here, this is where this part of the definition, so it's telling us how far away a score is from the mean in units of standard deviation. Do we see that now? Yeah. Yay, I like it when connections like that are made, right? So now we go back and we see, okay, this is what we're talking about. Okay, so this middle point right here on a z-score would be 0. Okay, the z-score would be 0. We can move it on and see that it also coincides with the mean. Okay, and if you remember in that example where I think it was Robin scored a 54, which was the mean on that exam, her z-score was 0. Okay, and the reason why the z-score is 0 is, remember, a z-score is saying, how is that score deviating from the mean? Well, if you are equal to the mean, you're not deviating, right? You are equal to the mean, okay? So that's why a z-score will be 0 if you are equal to the mean. And that's why a normal distribution and this z distribution fall in line, because it's just perfect like that. It just works that way, okay? So let's just take it a little bit of a step further. You can see here and just kind of look at these numbers, okay? So 115 here is 1 standard deviation above the mean. 85 is 1 standard deviation below the mean, okay? So a range of 85 to 115 are all people that are within 1 standard deviation of the mean. We would say they're pretty normal, okay? You start to get a little further out now and you're looking at something like 70 and 130, okay? Those are a little further out, and those are 2 standard deviations away from the mean, okay? I'm gonna do it like this. We could kind of draw it like this or something. I'm gonna color this in right here, okay? Let's go back to my yellow, and I'm gonna color this stuff in. Now, I want to explain what this is, what these colors are, and what I'm kind of shading in here, okay? This is the normal distribution. And I might have said a long time ago that we can imagine this imaginary line over here, and this would be frequency. You can think of it in terms of, you know, millions of people, okay? If we're looking at IQ and it being, you know, pretty normal for our population, at that point we're talking, you know, almost hundreds of millions of people, right? So I like to think of this normal distribution as a wave, okay? And I like to have people imagine there's a bunch of people in here, okay? They're all up here in this wave. And there's hundreds and millions of people all in here, okay? When you see that high part, the yellow part, if it's a wave and there's millions of people in there, that's going to be the most crowded part, right? More people can fit right there in the yellow part. You do have people over here, but it's starting to get a little squished, right? It's starting to get a little squished, and not everybody, and they're getting kind of pushed aside, and not everybody can fit. Now you can imagine even fewer people are way out here. Very few people, right? Because they don't fit and they're really getting squished, right? I can even draw their little heads in there. And then you can imagine even fewer people way out beyond, right? Even fewer people way out there. That's why it's so rare that Einstein was out there. These are truly your outliers, okay? Let me do the course. Oh, sorry. Corresponding colors over here. Oops, not blue, our pink. Okay. So imagining the people there, how many people, and so on. Now, the cool thing about a normal distribution is, and a Z distribution is, a normal distribution is mathematically defined. Really, really, really smart people somehow came up with the math that defined this. And I don't know, it just is. These numbers are set, they're permanent, they're not going anywhere. And we can use it to like predict, I guess you could think of, or find out what's the probability that somebody would have an IQ of 115. What's the probability or the percentage that somebody would have an IQ of 15 or 85 or 160, okay? So this is a table that I need out of my book to give you those exact numbers. I don't want to try and guess it because I know me and I know I'll mess it up, but we'll save that and to go over more about what these numbers are and what the corresponding like percentages are. But using those numbers, that's where they tell you you're in the 50th percentile or you're in the 75th percentile, okay? So let's see, just looking at it a little bit, you can see where, say, Einstein, right? We'd have Einstein way over here, okay? Einstein. Did you watch Forrest Gump? Have you seen Forrest Gump, right? Yeah. One of the things I love about Forrest Gump is just the editing and the writing of that movie, where it seems like something happens and then the very next scene kind of like counteracts it or contradicts it. But one of them was where his mom tells Forrest, don't let anybody tell you you're different. And then the very next scene was the principal of the school going, well, your son is different, right? And so what it was is he showed her kind of like a standardized test, I guess, and where Forrest scored. And he showed a range of like where all the normal people are, right? And then Forrest was just underneath it, right? He was just barely there. I don't know exactly what Forrest's IQ is. I think somebody looked it up and I don't know, you guys could Google it and let me know. But in whatever that standardized score was in the test, they had him just below here. They had him somewhere in here, right? I don't think his IQ would be that low. I think this was some standardized test that they used. It looks like Natalia might be typing and looking it up. You are? Okay. Oh,
I'm typing up notes just to make sure I'm getting everything down because if not, I'll forget this.
Okay.
Yeah,
I thought you were Googling, Forrest Gump's IQ.
no,
No.
I love I love I love the movie. I watched it with my mom. It was a good movie.
Yeah, it's a good movie. So, but we'll just, okay, so she's not looking it up, but so we'll put Forrest, I don't know, somewhere around here maybe. Okay. Bad handwriting. We'll put Forrest right around there. So Forrest, you know, he wasn't so smart, right? And there's not very many people like Forrest walking around, you know. It might seem like it, especially when you're driving and there's traffic, you're questioning everybody's IQ, but it's really not that common, right? It's not that common. Most people are within one standard deviation of the unit, of the mean. That would put us at 85 to 115. And then you could bump it out and say, you know, in fact, I know this one, it's about 95% of people walking around are going to fall in between 70 and 130. Okay. That is most people walking around this planet. Okay. Have you guys ever heard of Mensa? Mensa? Okay, not the Spanish term, not the term in Spanish. In Spanish, we mean it like ay mensa, like, and they mean it as like a dummy, right? Like a dummy. I don't want to say anything worse. They mean it as a not so smart person. Well, the real Mensa, which I wonder which one came first, is a group of really smart people. And you can look it up. It's Mensa, and I don't know what it stands for because I'm not smart enough, I guess. Right? I didn't get the secret decoder ring. No, you can look up Mensa, and in order to get in, you have to have an IQ of 130 or higher. You have to be really smart, and that is not a lot of people. That's not a lot of people can meet that requirement. So that's a very special group of people. Yes, go ahead,
Yeah,
Nathaniel.
I actually searched up the IQ of Forrest Gump.
Oh, you did? Okay, where is he?
It says apparently that he's around score of 75.
Okay, yeah, I didn't think he would be that low.
I don't know. I mean, this is what Google
Yeah,
says.
well, yeah, I mean, and Forrest is a made-up person,
Yeah,
right? So yeah, but that makes more sense. I think the one that they were showing in the movie was just some test, you know, that he had to take to get into into that school, but like an SAT type thing for the school. But yeah, so he would be right around there, and you know, he could obviously live on his own, he could function and everything, but so why I show you this, and this stuff does not even come up till chapter 7, but and you might be really confused right now, and I understand that, but I think it's just to start to show you a z-score, the normal distribution, how they can align with each other and how they can overlap. Let's I'm going to erase all this real quick if anyone wants. I don't know. I'm just going to take all this stuff off real quick. Okay. I'm going to leave the Z there. All right. I'm going to leave the Z scores. But now let's look at this information that was back over here. Okay. 54 was the mean, and 10 was the standard deviation. Okay, so I can go right here and I could say, okay, 54 was right here and 10 was the standard deviation. So this would be 64, 74, 84, 94. Okay, we're going to go down 10. 44, 34, 24, and 14. Okay. Now we can see, where did Chris, Robin, Marty, and Terry fall on our normal or on our Z table or our Z distribution? Okay, so let's see, 76 and then 58. So Chris, a 76, I don't know, somewhere right about here, right? Was Chris. We know Robin was right here. I already forgot the other, 58. The other two were somewhere here. Who was it? Marty and Terry. That's even worse, Terry. I'm trying to write small. Okay. So really ugly, but this is what this is showing us, is that all of them are in the positive. They're above the mean, or at least like Robin, she's equal to the mean. So even though this test score didn't look very good, and maybe they weren't very happy with the actual score that they were looking at, they can see here that compared to the rest of the class, they're performing pretty well. And in fact, Chris is doing quite considerably well. Chris is above 2 standard deviations above the mean, right? Or yeah. Marty and Terry are still above the mean, and Robin's equal to the mean, right? We, in this instance, we'd be a little bit more concerned of anybody who's way out here, right? They would really be showing that they're not doing quite so well, okay? And so this is one way that you could take sample data like this person had here. They standardized their exams in intro psych or whatever the class was, and then used it so that people could see Z-scores and they could see where they fit, okay? The other cool thing about a Z table or Z-scores is you can then standardize another test and put it on the same distribution, and essentially it allows you to compare apples to oranges, right? We always say you can't compare apples to oranges. Well, if you standardize them and you put them on a Z table, you can, okay? So let's see what this other table over here was telling us. I'm gonna have to get rid of us real quick. So this is test number 2. It has a completely different mean and a completely different standard deviation. And now we could see if their scores were such as this, how are they doing? Okay, how are Chris, Robin, Marty, and Terry doing? Okay, so gosh, I don't know if I'm going to remember those for some reason. Let's see. Okay, 76. Oh, Chris got the same score, right? A 76. I would have to erase all this down here actually, because what happened? Okay, got it. Why isn't it doing it? That is so weird. Okay, looks like my computer or something froze. I'm not sure what the deal is, but let's say we had new information. Why is it doing that? Can I write with this one? Yes. Why aren't you happy? Oh, well, that's going to be annoying. Okay, there we go. Sorry, guys. So we could take that same or that new information that we have from the second test and transpose it and put it on here. So let's see, 86, and it was an 86 was the new mean, and we went in increments of 6. So that would be 92, 98, what, 104. I'm going to stop there. Then we go down 6, right? 80, 74, and 68. And I'm going to stop right there because it didn't seem that anybody else had scores that high or low. I don't think, no. So Chris stayed consistent with the 76. But now you can see where that 76 falls in relation to how everybody else was doing, right? Let's see. Oh, Robin is just average, right? And that is not necessarily a bad thing when we're talking about, performance on exams, right? Let's see. How did Marty got an 82? And so an 82 would be somewhere around here. And then Terry got a 90. Oh, Terry's doing good, right over here somewhere. Okay. So even though Robin on the first test got a 76 and was well above the mean, was right 2 standard deviations above the mean, a 76 on the second test earned her almost 2 standard deviations below the mean. Okay. And so this information just allows us to really look at how people compare to norms or normal data or standardized data. Okay. And I think some of the biggest like messages that you're going to want to carry forward with you is this idea of this normal distribution, thinking of it in terms of frequency. The highest point up there, or all that yellow part, is where most people are. Okay. It starts to narrow out in what we call the tails. The tails of the distribution start to thin out, and not as many people fit there. Okay. And so now we can see that like the pink and then certainly the green is what we would say are more outliers, or they're not very common, or they're unlikely. Okay, so being able to just kind of visualize this distribution like this will help us going forward, and will help you going forward when we start talking about more kind of complex statistics, because it's all in one way or another based on this distribution. Okay. So this is what someone might say is a normal curve, where you fit on the curve, right? Where are you in terms of the curve? And that's what they mean. Okay. All right. Any questions? Other than like everything. I know next week, don't stress about the syllabus right now and how things are going, because we're just going to continue with this information, okay? And we're going to get it down. We're not going to move on until we all know what this part is and what we're doing, okay? So don't stress about that, okay? Any questions over just some of the stuff that we talked about today? I know that information might be muddy. I know that. Okay. And I'm okay with that right now. Okay. Yeah, no. Okay. I don't even think I'm going to assign anything yet other than just read through chapter 5. And you don't even really have to read everything, because like I said, he starts talking about effect size and stuff like that. So you can just read a little bit about z-scores. And then if you want, you could skip over to chapter 7 and start reading over the normal distribution, a theoretical distribution, a normal distribution, and kind of start looking over that stuff. Okay. And just let it, just kind of let it soak and simmer right now. And then when we get back next week, we'll start hammering a little bit more. And I think it'll come together and make more sense. Okay. Yeah. All right. Are we cool? Cool beans. Okay, Natalia needs to go study for physics.
Are we doing the example below, or are
Oh,
next class, or what's your?
You know what? Let's see. It's all there. You guys want to take a stab at it, and then we could discuss it the next time?
Okay.
Just so let me start you off. They tell us, I'm like, does it tell us? like trying to figure out which one is the mean. And let's see, the field of contestants was different each year. The gameplay in the final round was different. The annual winners, amount of time the winner played before losing the final round. Contest statistics for each year are shown. I'm assuming the annual winners, amount of time the winner played before losing. Like which one is the mean and which one is the, I'm assuming these are the z-scores for that person, and that this is the mean and the standard deviation.
Okay.
Do you think? I can tell you right now, everybody's just above their own, the mean, or otherwise it'd all be below. I think that's how they mean it. I think they're saying that these are the raw scores.
Mm-hmm.
These would be the means, and these, of course, it's telling us is the standard deviation. So
Okay.
say we were going to
Would
do,
we have to find them? So everybody has their own mean, or what would be the mean itself?
yeah, that's right. So it's telling us that everybody has their own mean and has their own standard deviation.
Oh, I see.
Because look, everybody is playing a different game, right?
Oh.
Donkey Kong. So they all have like kind of, it's like comparing test 1, test 2, test 3, right? They're different. They're different, right? Donkey Kong is different, played differently than Pac-Man. And so Zach, we could see here, whatever 32 minus 28, that would be, my computer is gonna die. Is that 4 divided by 2, right? So Zach had a z-score of 2, I believe, right? Is how I'm just by eyeballing it. So then you could do Slater. Oh, this is so funny. They use the names from Saved by the Bell, and then Screech, and then Lisa, okay, to see how they all performed within their own competition or their own contest. So yeah, if you guys want to go through and do those, or you can shoot me an email, or maybe I'll post it up later. Hey, these were the z-scores, and you can just kind of check to see if you did it right. Yeah, you can check I'll put that up. I'll put a check your answers kind of thing. So the reason why z-scores are kind of cool, so say you had these 4 friends, Zach, Slater, Screech, and Lisa, and they all went to this contest and they all played different video games. And Zach's like, I won. And Slater's like, well, I won mine. And Screech is like, I won mine. And Lisa's like, I won mine. Well, okay. But among those 4, maybe they're super competitive and they're trying to say, well, I'm better because Donkey Kong is harder than Pac-Man, or, well, I'm better because Frogger's a totally different type of data set or visual, whatever. So among those, this is kind of the comparing the apples to oranges, right? How can we, among those friends, figure out who did better among their data set, but once you compare them to other people or their other winners. So, so we have to see who has the higher z-score. All right, whoever has the higher z-score means they were further away from their mean for their video game, and therefore you could kind of argue that they did better. Okay, so yeah, thank you for bringing that up. I guess I was gonna go, I even gave myself a blank, oops, I did not mean to do that. I even gave myself a blank slide over there to work those out, but you guys work them out because we're kind of going over, and I'll post up a check your answers, okay? All right. Thanks for reminding me. Okay, guys. Well, you guys go on. Have a great day. Stay safe, stay warm, stay all that good stuff, okay? All right. Okay. Thank you. Bye. Bye.
I have a quick question for
yeah,
you,
yeah.
Ms. Sherman. Okay, I was trying to email you this, and for some reason, it's telling me that the file's too big.
Yeah.
So I can take you I have it in a flash drive, so I can just take it to you.
Yeah.
Or
It's okay, because now I just got that email, that I'm
Okay.
able to go in, you know what I mean? And so, it's okay. Yeah, I promise
If
you.
I can figure out, like, maybe if I can use a different email, I'll probably use my husband's that probably lets him send bigger files than mine. I don't
Yeah.
know how the setting is, but it won't let me. I tried to airdrop it to you too.
Oh,
It gave me an option to airdrop mail or something like that. So I tried it. I don't know if it worked or not.
okay.
But that was one. And two, I don't know if you got my message during the weekend about, I was trying to get the recording from the previous times.
Oh, uh-huh.
And I couldn't find it. I didn't know where. I know you said something about the YouTube and I
Uh-huh.
looked you up. I know I didn't find a link if you had put a link up for your YouTube page. But I
Uh-huh.
looked you up and I still couldn't find anything. So
No,
I
okay.
don't know.
So,
I don't know how I can access these recordings.
okay, look, can you see my screen?
Yes.
Okay, so, right, I think you just click on there. I
Let me
think.
see. Let me go to
I'm
your
like it.
course.
See, it works. Ugh, I don't want to. I don't like watching myself. Um, yeah, and so
It's
see,
because it gives us a different like it gives me a different screen than yours.
yeah,
Let me see Zoom presentations. Oh, I see it. Yes, yes, yes.
you
I don't
do.
know why I didn't see it that day. And I was
No,
like,
that's okay.
I was breaking my head trying to finish.
You're
Like
like,
I left the test till the last day because I was trying to access
oh,
these and
find.
I couldn't see these and I was like, wait, where did she say she was gonna put them?
Yeah. Well, yeah,
So
and
I
it
sent you
probably.
a message and I
Oh,
never heard from you. So I was like,
I.
oh,
I'm
okay.
sorry. I don't know why I didn't get the message.
It could have
But
been because I sent it to you on the Blackboard, not
oh,
on your email.
yeah, I'm not the. Yeah, yeah, I'm not the best at seeing the Blackboard
The Blackboard.
messages. Yeah.
Okay.
Um,
Sorry.
No, that's all right. And I apologize for that. So I'll open the test for anybody who needs to go in, wants to take another stab at it. You know, do that other
That one.
attempt.
Yes, if
Yeah.
you could
Okay.
please. I mean,
Yeah.
I did okay in the quiz and the test wasn't
Yeah.
too bad, but
Yeah.
I just used what is that word called when you just use like you guess but your best like
Yeah.
at your best.
Yeah. You're using your best guessing. Yeah. No problem.
Yes.
No problem. So yeah, I'll go in and open that up. Okay.
Okay, sounds
Yeah.
good. Thank
And
you. I
that's where they are.
appreciate it.
So they're under
Yes, I found
Zoom.
them.
Okay.
Zoom
Okay.
presentation. Yes,
Yeah.
thank you.
Which doesn't make sense now, but I guess they are still kind of Zoom presentations, right?
Yeah,
Yeah. Okay.
thank you. You have a
Okay.
good one.
Thank you. You too.
Thank you. Bye-bye.
Okay. Bye. Susanna, are you good?
Sorry, I couldn't unmute.
Oh, no. That's all right. That's all right.
Yeah, I'm good.
Okay. Okay.
Thank you.
Okay. You're welcome.
Oh, you know
Have a
what? I'm
good.
sorry. I do have one quick question.
Uh-huh.
Is it just for the test that you're going to leave open, or is it the quiz as well?
Oh, I can open the quiz. You want to? Yeah. I can leave that one open if you want to take that again. Or,
Okay.
yeah, for sure.
Okay.
I'll go do it right now.
Thank you. Have a
Okay.
good day.
Thank you. You too.